Hey everybody, this is Alex Merced, and you're listening to a new episode of Gnarly Data Waves presented by Dremio. And this week we're going to be talking about building a data lakehouse on Azure Data Lake Storage. Now, before we get started with that, I want to make sure you know that you can head over to dremio.com and try out Dremio Test Drive, so that way you can get your hands on at no cost, no obligation on trying out Dremio. Make sure to pick up an early copy of Apache Iceberg, the definitive guide, slated for release early next year from O'Reilly. Just scan that QR code and uh, get some early chapters to read. Many great new episodes coming up over the next several months over here on Gnarly Data Waves. So next week I'll be presenting on versioning data in the data lakehouse, so things like file, table, catalog versioning, Merge Journey to Unified Analytics with Dremio and Generative AI, Apache Iceberg Office Hours, all the way through the end of August, where we'll be doing using Dremio and DuckDB together. Okay, so make sure you're here every Tuesday at the same bad time, same bad place to never miss an episode. And make sure to visit Dremio at any of these events. So if you're in New York in July, these AWS Dev Day events, or if you're in San Diego in October for Coalesce by DBT, or if you're in London or Paris in September for Big Data London and Big Data and AI, all sorts of great events where you can visit the Dremio team and oftentimes pick up some cool swag. Now, with no further ado, let's get started with today's episode on building a data lakehouse on Azure Data Lake Storage. Presenting today, we have Ellie Vale, a product manager from Azure Data Lake Storage, Microsoft, and Tony Truong, senior product marketing manager at Dremio. Ellie, Tony, the stage is yours.
Hi, everyone. Thank you so much to Tony and to Dremio for having me here today. My name is Ellie Vale. I am a product manager with Microsoft. I specifically work with the Azure Data Lake Storage team, and my focus is mostly on data protection features such as immutable storage, soft deletes, and snapshots. So today, I wanted to talk a little bit about kind of why you would want to be on the data lake and kind of what assets that would give to you. So as we know, data is a strategic asset in today's world. Everyone has data, every company has data, and it's kind of the most important thing that we have, and it's the most important valuable asset that we have going on. And getting value from the data is really at the heart of everything we do. Like, data is our product, data is what helps drive our companies forward. The blob and data lake storage really does is it encourages you and empowers you to drive forward your digital economy. It gives you a lot of offerings that you can use your data in a better, more efficient way, such as being more scalable, durable, and available. It gives you security and compliance options, as well as security and governance options. It's a lot more cost efficient than using on-prem data solutions. And it also gives you comprehensive data management features and availabilities. And it really is the foundation for demanding workloads so that you can use your data in such a way so that you are having less throttling, you have a lot more feature options, and you don't have to build and use all of these things on your own. Some of the key blob and data lake storage use cases that we really encourage people to look into are machine learning and AI, analytics, HPC, BCDR, and cloud native apps. There's a lot of different options within all of these that you can kind of use a lot of our features and functionalities to go into any one of these in a lot further depth. Additionally, one of the biggest, most important things is that you can use the data lake and the blob storage from any one of the protocols. It's a single storage platform, and you can access it through various APIs, through NFS, through SFTP. And all of these different API options and protocol options are great for using it from a variety of different sources. These, of course, hook up to our hierarchical namespace and common blob storage foundation, and give you a lot of different options so that you can use your data that's the best way that you see fit for your business and your workload. Now I'm going to hand it over to Tony to talk a little bit more about how Dremio works with the data lake.
All right, thanks, Ellie. So as we jump into the data lakehouse content, I'd like to give you a little bit more context on how we got here. Everyone knows the story with data warehouses, with its fixed compute and storage, and as your data grows, you have to add more hardware and licensing to keep up with this. Over time, we saw the need to analyze big data, so unstructured and semi-structured data. And then we saw the emergence of Hadoop, which added to an ecosystem that can now start analyzing a variety of data sets. But the problem is it shared similar pain points as the data warehouse, such as fixed compute and storage capacity. And to really keep up with the growth of data, you had to throw more compute and hardware at this. And this was still mostly on-prem. And with Hadoop, it was really easy to spin up, but it required a lot of efforts just to keep the lights on. And then we saw the emergence of cloud data warehouses, such as Snowflake, right? That could offer cloud agnostic compute. Although storage and compute were now separated, customers are now finding that their data is locked in proprietary table formats, with the cost of compute rising in a closed data architecture. And now we start to see the data lakehouse coming in, and this is a more open approach to data architecture, and I'll go over that in the next few slides. Now, this is all still happening, right? On this slide here, companies are still trimming down. They're wanting to do more with less, essentially competing on economics. Line of businesses need faster access to data that they can trust. And centralized IT teams are still getting pinged and crushed with data requests while fixing and maintaining complex ETL pipelines. But the business still needs to deliver at a much higher rate and velocity. And decentralized teams need to continue to govern the individual teams and data products that they create for mission-critical applications and reports. And in this next slide here, I'm going to show you what I call the traditional analytics architecture. With most companies that we've worked with, they are running a flavor of this architecture. Yours may look and feel very similar to this, but what's essentially happening is you have your business data that's flowing from the source system into a data lake and or on-prem database or data warehouse. And for a lot of folks that are running cloud data warehouse architecture, they're moving data from the data lake into the data warehouse. And when end users need access to this data, the central team will copy data from the warehouse into BI extracts and or cubes in order to get performance in their reports. And we've talked to a lot of customers and prospects who have more copies of data than you can count on your fingertips, right? And many of these are sprawled out across data marts, in the lake, in the warehouse, BI tools, and offline copies. So essentially, a data governance nightmare. And with this architecture, your data is locked into one format and query engine, right? So in this case, it'll be the enterprise data warehouse. And you're sort of dealing with multiple copies of data as a result, which results in slower time to insight for the business, and your data is not securely governed for the enterprise. And this really creates a lot of complexity and challenges. And this is where the data lakehouse with Dremio really shines. With Dremio, you're able to really unify data that's in your data lake, such as ADLS, right? We're unifying data in the whole ecosystem without having to copy it, regardless of where it lives. Dremio is really one of the few and or only platform that allows you to build a simple data architecture in and around your data lake and interact with that data, whether it's in the cloud, on-prem, or hybrid. So you're able to query your data, create a semantic layer across that data without having to copy it anywhere else. And this essentially eliminates the need for a BI extract. So you don't have to worry about paying for licensing and compute in BI extracts. And then for the data warehouse, right? If you've already invested heavily in a data warehouse, Dremio can connect to that data and join it with other data sources across the enterprise. And with Dremio, we have a query engine, which I just kind of talked about. And then we also have a data governance layer via our semantic layer, right? So you're able to create views of your data without creating copies. You're able to use Dremio to discover and validate that data. What this means is you can go in to your data that's connected to Dremio, you can search it, and then you can use the wiki to add business context. We've had customers come to us and say, hey, we have a lot of tools internally that's used as a business glossary for the enterprise data, but with Dremio, we're able to replace those tools and add those business contexts right into the wiki feature, and then use the data lineage feature to show end users where that data is coming from. So this, as a data consumer, whether you're using it for data science workloads or as a end users in your downstream apps and BI dashboards, you can go into Dremio and you can validate that the data that you have is coming from the correct source. And with Dremio, basically, we help you eliminate data copies. This makes self-service really easy for end users and unlocks data engineering productivity. And your data engineers are no longer spending time maintaining complex ETL pipelines where you're making copies, right? You're really unlocking them, is how I would put it. You're taking these data engineers and moving them upstream or downstream to help support the enterprise data initiatives. Now, let's go ahead and look at some of the levers that are driving digital and AI transformation. On the left-hand side, I'm going to talk about the solution area where Dremio can help. Right, for companies that want to modernize their data and analytics infrastructure, Dremio can help in these core areas. So data mesh, right? You want to move from a centralized architecture to decentralized. We've had customers that to help support data consumers and data providers. And so this helps accelerate time to business with their data, helps simplifies data architecture. And then with Hadoop, right, we have customers that have on-premise Hadoop, such as HDFS, Hive Query Engine, and they're looking to modernize and go to a modern data lakehouse architecture on ADLS. And so we have a whole session on that from a different webcast you can check out later on, but I won't dive into that this session. But essentially, we're helping them remove the costs associated with Cloudera and getting off of Hadoop. We have data virtualization, which is essentially, data mesh and Hadoop put together, right? You may have data sitting on Hadoop, and you have data sitting in relational databases that you need to join together. And that's all part of the journey. And part of that journey with Dremio is we help you unlock that data, join those data together, and create business insights without creating copies. And later on, as you get further down the maturity path towards the data lakehouse, you can really start to do things like migrating some of these data warehouse workload to the cloud. So you're essentially migrating these warehouse workloads to the data lake and eliminating the copies of data. And on the right-hand side, this is going to be more on the business side of things, right? So on the left-hand side is more of the how, and on the right-hand side is more of the what. And I'll give you an example. You're building out new projects, right, such as Customer 360. And one example here is accelerating new business opportunities. If you are in insurance, right, you want to drive insights quickly before policies lapse, which increases the hit rate for cross-sell and upsell opportunities. And by reducing the time to close an insurance policy from months to days, you're going to be able to add to the bottom line of the business. And in supply chain, right, you want to unify product analytics, inventory count to identify supply chain challenges across various channels and regions impacting market share and profitability. And so these are just business cases that can help drive digital and AI transformations. Let's go ahead and take a look at an example of a customer that's using Dremio and ADLS to deliver product analytics. So this is a top 14, 15 company, right? Before Dremio, what they were trying to do was they need to analyze product usage across their portfolio of product offerings. And so they had 50 terabytes of data and growing 5 terabytes of data per day. They had, like a lot of companies, they had a lot of complex and siloed ETL pipelines and Spark jobs. And the current Presto query engine was not an effective solution. They needed to get data into the hands of end users without creating multiple copies of data. And so their internal tools required a lot of data movement. And one of the quotes that they provided to us was that, data pipelines were hard to create and even harder to maintain. And they chose Dremio as the data lakehouse query engine, which offered a semantic layer. And now their end users are able to query data and run fast BI queries using Power BI directly on top of ADLS without copying into a data warehouse and BI cubes. And essentially what's really happening is they're increasing productivity for their end users and data engineers. And then it unlocks data engineers because it reduces the busy work that they had to do with maintaining and fixing these ETL pipelines. And then all they really need to do is really focusing on one single copy of data and shifting their focus onto higher value projects. Another customer of ours is NCR. They're now running dashboards up to 30x faster. And before Dremio, they were using a combination of legacy data warehouse and Hadoop infrastructure. And similar to the first story that I told you earlier, they needed to support their business ability to cross-sell, upsell, and understand the usage of their customer base. And, their data pipelines took 2 to 3 months for critical and large data sets. So this really slowed down their analytics development and created a lot of silos across different teams. And in the end, this created long turnaround times for data requests. And with Dremio, what they did was they were able to move the data from Hadoop and on-prem legacy data warehouse to ADLS. And using Dremio to build a data lakehouse and query that data with one copy of data. And not only are they seeing one copy of data, they're getting immediate performance over what they had previously on Hadoop. So we completely ripped out their Hive query engines and retired their Cloudera licensing. And with Dremio, NCR were able to get faster time to insight, and they saw significant performance improvements in efficiencies, and which helped reduce revenue leakage from time wasted during data analysis. And they were able to see queries on the dashboards ranging from 10x to 30x faster, and typical complex queries are now delivered in less than 30 seconds. And the business outcome here with NCR is that it helps improve the end user customer experience and offer a more tailored services for their customers. And with that being said, let's go ahead and jump into a demo where we'll show you how to use Dremio with ADLS and Power BI. And I'll hand things over to Brett, who's our partner solutions architect.
Good day, everyone. My name is Brett Roberts, and I am going to show you how Dremio can connect to your Azure Data Lake Storage and how you can use Dremio to query data on Azure and then visualize that and run analytics on Power BI. So first we're going to log into the Dremio user interface here using my email. And what you see here is the Dremio home screen. And I'm going to quickly orient you to a couple different areas within this home screen. On the bottom left here, you see sources. These are all the different data lakes and external data sources that you can connect to with Dremio. And it's very easy to add a source like a Azure Data Lake Storage by clicking on Azure Storage and adding and naming the connection, adding your account name, and then authenticating. And it's that easy to create a connection. And you can see here we have an example of just that, where we are connected to a Azure Data Lake Storage account. You can also connect to external sources like Microsoft SQL Server and even Microsoft Azure Synapse. Up here on the top left is what we call spaces. And spaces is one of those building blocks of the semantic layer. Create a series or a number of different directories for users to save views of the data. Remember, Dremio doesn't copy or store data, but we do create views or virtual data sets, which is really just a SQL syntax or SQL statement on top of that physical data that's sitting in Azure. So these views are different, or these spaces are different directories, like business, for example, where you can store virtual data sets for teams to access. And organizations do this a number of different ways. You can create spaces based on team, role, location. It really just is a directory for you to store and collaborate across organizations. And then in the middle here, you have your home spaces, which is really set for you, the user, to work on data, upload Excel spreadsheets, create views that are maybe not ready to share with your organization or your team yet, but you have this space here it's kind of like a workspace. So now that we've oriented to the Dremio home screen, we're really going to show how users can use Dremio to interact with the data directly on their Azure Data Lake Storage and then connect that to Power BI. So I'm going to put on my data consumer hat for a second, and I'm going to access Dremio, and I'm going to search for a data set that I need to run to create some dashboards within Power BI. So I'm going to go into our Dremio search bar, which searches the spaces and all the different data sets. And for this example, I'm going to search for NYC taxi data. So I'm going to type in NYC and taxi, and Dremio returns all of the physical data sets, which are just tabular views of the data in the lake, and all the virtual data sets, which are these green tables that we talked about earlier. And you can see that Dremio's returned all the different data sets that have NYC or taxi in the title or in one of the fields in the data set. And there's a couple here. But you can see this one here, NYC trips, also has these tags here: gold, cab, taxi, NYC. Tags are another fundamental building block of the semantic layer that helps data consumers like myself easily understand what the data set is, and helps me identify what I'm looking for a lot quicker. I might not know exactly where all the data is, or I might not know what data sets are out there. The tags help me quickly identify something that might be relevant to my search criteria. So let's click on this data set here, and you can see that Dremio brings up a preview of the table, and you can see all the different fields here. As you scroll, we have pickup dates, drop-off dates and times, passenger counts, trip distance in miles, which is interesting. We have some geographical data in longitude, latitude, and so on. If we look at the top here, we have a couple different tabs that we can toggle against, and let's look at catalog. Catalog is another semantic layer building block which allows organizations to provide a wiki-like experience to each data set. And you can see here that the data owner created this wiki to show all the different dimensions and measures, so all the different fields in the data set, the volume of this data set, so I see here this is 1 billion records, so a very robust and large data set, and then data quality and description of the data set as well. So as a data user, this is extremely helpful for me because I can very easily either validate that this is the right data set that I want to use, or I can validate that this isn't the right data set and move on to search for another one. But this looks like a very robust data set that has all of the right fields for what I want to do and the analytics that I want to build in Power BI. The third tab here is a graph, and this shows a lineage of the data set. So you can see here that this data originated in the Azure Data Lake Storage. There was a parent data set, and then this one here is the child data set with a ton of children data sets that were derived from this as well. So it's been used by a lot of people in my organization, but this is, I can see where this data set came from. And then the last tab is reflections. And reflections is one of the acceleration technologies that are built into Dremio to help organizations really get that scalable, fast BI that the enterprise needs, right? When we think about 1 billion records, which is in this data set, traditional query engines might take a while to query that. But reflections is one of those acceleration technologies that Dremio has to help speed up that query, as you'll see in Power BI. And really what a reflection is, it's just think of it as a materialized view of the data. And there's a couple of different ways that you can apply that. You can apply that at the row level using a raw reflection, or in this case, an aggregate, which is really doing pre-calculations or indexing these dimensions and these measures, and then writing that as a Parquet file back on your Azure Data Lake. So now that we've validated that this is the right data set that we want to use, this is something that is of interest to us, let's go ahead and connect this to our Power BI instance. And we're going to do that by clicking this Power BI button here. That creates a PBIDS file. And we're going to click on that, and that's going to automatically load our Power BI desktop instance. And it's going to create a connection to Power BI and to Dremio, and we're going to load the data. This is going to be a live query. And you can see here that just by clicking that PBIDS button, we automatically not just create the connection to Power BI, but we create the connection to the table that we were looking at in Dremio. So we didn't have to go through the schema, we didn't have to go find the table, we didn't have to load anything. The data is still sitting in Azure today. Dremio is providing a live query back to Azure when Power BI sets a SQL statement back to Dremio. So you can see here we have all the same fields that we saw in Dremio. Okay, so now that we're in Power BI and we're connected to our Dremio data set, we can start to build our dashboards and our visualizations. And we're just going to do a very quick one real quick to show how this works. And we'll do this by selecting a chart. We'll do pickup date by the count of records. And you can see here that we are looking at the count of records by pickup date for the duration of this data set, which again, if we remember going back to the catalog in Dremio, was 1 billion records. And you can see here that you have a ton of results, but Dremio returned those results in near real time. So if we go back to Dremio, and we go to the Jobs tab here, you can see that this was the job that we just ran. You can see pickup count and pickup date by pickup date, and we show you a duration of sub-second. So sub-second query time on this billion record data set. And so what happens is when we set the parameters in Power BI sends a SQL query back to Dremio. Dremio runs that query on the Azure Data Lake Storage and then returns the results. Now, if we went back to Dremio and we went back to the NYC taxi data set that we just had, there's a couple other interesting things that we can do here. One of the things is you can do some last-minute transformations, create some calculated fields within Dremio. So if you go, for example, look at trip distance in miles, maybe for the purposes of this experiment or this exercise, we wanted to see this in kilometers instead. So we could very easily click this drop down here, create a calculated field, and apply a calculated field of multiplying trip distance in miles by 1.6, which is the kilometer formula. Change that field name. We're going to keep miles because maybe that would be interesting to for part of our dashboard or part of our visualizations, but not for all of them. We're going to apply this. And Dremio actually writes the SQL for you, but it created a additional field here, which is trip distance in kilometers. We could also create a join in Dremio by joining data sets from additional tables within Azure or from data from other sources like Postgres or SQL Server. And Dremio recommends joins that have been used by people in the past, or you can create a custom join and scroll or search the directory of different data connections and views of the data to find a data set that's right for you. For the purpose of this, we're just going to take the recommended, which is weather and NYC. So that what we're going to do is create a new table that's a join of taxi data, but we're going to supplement that with weather data and see how weather impacts taxi usage, passenger behavior, passenger tipping within NYC. So we're going to apply that. And what you see here is, again, if you look at the SQL runner up here, Dremio has written all the SQL for us. We haven't had to write any SQL today, which is always a good day. And if you scroll to the right here, you now have all these additional weather fields to supplement our taxi data. So we're going to save that as a new view. I'm going to save that in my home screen. I'm going to call that NYC plus weather. And I'm going to save that. So that was just a very quick intro into some of the capabilities that Dremio can do and how Dremio really helps Azure users connect to their Azure Data Lake Storage and then really provide a full solution end-to-end from the data lake all the way to the consumption layer with Power BI.
Okay, thank you, Brett. Now we'll go ahead and jump to Q&A. If you guys have any questions, feel free to drop it in the chat below.
I'm back. Okay, I want to thank Tony, Ellie, and Brett on a wonderful presentation, but now we're going to head on to the Q&A. So if you have any questions regarding the presentation, just put them into that Q&A box and we will begin taking those questions. And I have a few questions over here. Let me just go find them. Here we go. Okay, for Tony and Ellie, first question. I have an SQL Server database and I'm copying it into ADLS. Would Dremio be a good fit for my use case?
Yeah, I can take this one. So that's a good question. So the answer is yes. So we've had customers who come to us because they're moving data from the source into data lake, and then in parallel, they're also copying it over into SQL Server and then copying that over into another consumption layer. And so with Dremio, what they did was they totally eliminated the whole copy process and just queried that data where it lives in SQL Server, and over time minimize the dependency on it. So the short answer is yes. So you can join data in ADLS with SQL Server.
Can you tell me more about Dremio reflections?
Yeah, Alex, do you want to take this one?
Oh, okay. Cool.
I think
Okay,
that's a good one.
reflections. Yeah. No, reflections are a really cool feature in Dremio. Basically, the way I like to think about reflections is like this. You have materialized views. Materialized views are a very typical technique you see in a lot of different databases, data systems, whatnot. But you have three sort of typical problems with materialized views. One, every time you create a materialized view, you're creating a new namespace. So now I'm not querying table A, I'm querying table A2. Okay, and two, you're creating a complete copy of that sub data set, that materialized view. And if you have another use case, you have to create another complete copy with another materialized view. And then the third issue is keeping them in sync. How do I make sure that it's doesn't go stale and is in sync with, so these are all things that generally either you have to manually kind of figure out, or different systems have different ways of figuring it out. In Dremio, with reflections, what they're doing is they're not necessarily just creating a straight up materialized view. You're creating different sort of basically composable Apache Iceberg representations that can be used for different use cases. And from the end user's perspective, they don't have to query a different namespace. If they were querying table A before, they keep querying table A, so they don't even need to know the reflections have been turned on. They're just going to notice that the table's faster. But you can actually create multiple reflections on the same table for different use cases. So I can create one that's partitioned and sorted in a different way than another. And then basically Dremio will figure out which reflection serves each particular query the best. They give you the best performance for all sorts of different types of queries on the same table. Plus you get the aggregate reflections that allow you to speed up like BI dashboards. So that way your Power BI dashboards can be nice and crisp. So reflections are essentially like a very, very souped up materialized views, but you can think of them as like, they almost take out some of the data pipeline work because you don't necessarily have to go create another table. You just kind of define these reflections. Dremio keeps them in sync. So all you have to really do is just have your data sets in Dremio, and it kind of takes care of all that, creating all those alternative versions of the data for those different types of queries.
Yeah, and great point, Alex. And I think also to add, we've had a lot of folks come to us and say, hey, we're spending so much money on our BI semantic layer licensing costs, because what they're doing is they're literally importing data from the data lake or warehouse straight into, like a BI tool. So that's another layer of copy complexity. And with Dremio and reflections, eliminates that need to copy data and licensing costs.
Certainly. Okay, another question from Merrick. What is the size of your Dremio cluster? And what is the configuration of your ADLS storage account? Premium, hot, cold?
Yeah, so I think the answer to that, to the Dremio one, I can answer. It really depends on what engine size you need. So if we're just talking cloud, it can range from extra small to extra large. And I think we use the M5D extra large, depending, I totally forgot, but it's somewhere on our website. I don't have that number off the top of my head.
Okay, and then yeah, and as far as like the configuration goes, I have a feeling that's more like a specific use case. So there'd be like that'd be for like a specific implementation.
Yeah.
So it can vary depending on your particular use case. Okay, then we have another question. Please compare using Dremio or Trino for getting data from the Lakehouse. So Sonia, is that how you want to handle that one?
Yeah, so I think, so this one, you need a lot more context to answer. It's not just like Dremio or Trino. So I think I'm assuming they're talking about open source Trino. So I think it really depends on like your deployment model, your use case, what data sources you want to connect to, and what sort of features you're looking. I'll speak for the Dremio side of things, because if you're, wanting to go to Dremio, right, you get everything we talked about in the webcast. You get that data lake query engine, you get the federated query engine, you also get the semantic layer, right? So now you don't have to get another vendor to do self-service, right? Create a semantic layer in the UI with Dremio, and then you have reflections, so you don't have to create BI imports. So you don't have to get something like, a premium subscription capacity. And then we also connect to all your favorite BI tools. So that's for Dremio. And then we also, we've had a lot of customers go head to head with open source Trino, and Dremio outperforms it almost all the time. So that's my answer. But like I said, it very depends on your use case. And also one more thing to add, like if you look at the engine behind Trino, it's initially built for ad hoc query. Dremio is built for, BI long, running queries. So if you need that interactive speed for BI workloads, then I would recommend Dremio.
Cool. Question for Ellie. Can you tell us a little bit about sort of like some of the exciting things going on in the ADLS world and Power BI world, that people should be keeping their eye on?
Yeah, for sure. So we work a lot with a lot of the different big data formats. So we are integrated with Dremio as well as Databricks, and we kind of have a lot of those options there. We also have a lot of new data protection features coming down the pipeline as well. We're doing a lot more with vaulted backup and object replication. And those are features that we just kind of encourage you guys to use to make sure that your data is backed up and protected. And yeah, that's just a little bit, but yeah, feel free to follow the Azure updates, and we have a lot more coming. So
awesome. Is there any like a particular like best place to go like follow these kind of updates? Like there's like a Twitter account or a particular like blog page?
yeah, so there's actually an Azure updates page. I can put the link in the chat, and that's where we put all of our new features that are coming out and all of the previews that if you're interested in trying, you're more than welcome to sign up for.
Awesome. Okay, I think we have, okay, I see one more question. Tony, how does the semantic layer work?
Yeah, so that's a good question. So the semantic layer, basically, we have something called spaces. Think of it as a way for you to create your domains. So you can create one for like sales, marketing, finance. This is just a very generic example here. And within that, you can create something called virtual data sets. Think of it as like creating data products. So if I'm in sales and I have a example where it's like all store sales, I can create one where it's only for the West Coast, and I can share that with Alex. So I can create that view called West Coast store sales, and without having to create any additional copies of data. And the cool thing about the semantic layer is that it has a low code, no code experience. And we have customers who, for example, MSK, they have folks that know SQL. We have, they have folks that are physicians who don't know any code, so they can just go in and modify the columns, edit the data, create views for themselves, and share with their team members. So it's a way to really create a one-spot data platform for you to share your data and easily curate it. So that's probably the best way I would explain it is, you get that self-service capability without having to learn a new tool across all the different teams. So it's one platform to share your data products.
Okay, very awesome. I think that looks like to be all the questions. So in that case, first off, I want to say, hey, everybody, make sure to continue tuning into Gnarly Datawaves every week at the same bad place, same bad time. And next week, we're going to be talking about Lakehouse versioning. So there's so many different ways to version your data on the Lakehouse now, whether it be at the file level, at the table level, at the catalog level. And next week, we'll talk about those different versions, the pros and cons of these different sort of levels of versioning, and so forth. So that'll be next week here on Gnarly Datawaves. Again, I want to say thank you to Tony and Ellie for being here today and being part of this presentation. It was enlightening, educational, and entertaining.
Thank you, Alex, and thank you, Ellie, and appreciate the crowd that joined us today. Looking forward to the next one.
Thanks for having me, guys.
Take care, everyone.
Thank you. See you all next week.